Okay, gang. Let's start over here with the increasing, decreasing. Okay, we already talked about, yes, it's a function. Domain and range are both all reals. There's no y-axis symmetry or origin symmetry. They're also going to be asking us, this is new in college algebra, okay, where is the function decreasing? Where is the function increasing? When we say our answer, we're talking about on the x-axis, okay? We use the x-axis as our numbers as to where it's increasing and where it's decreasing, all right? So I can see that right here is a spot that I want to look at. And right here, as far as where I change, I'm decreasing and then suddenly I'm increasing. I'm increasing and then I'm decreasing. Okay. So I want to look at those values of x. This is -1.5 right here. And this is 1/2. So from the time x is -1.5 until x is 1/2, my function is increasing. Whoops, -1.5 to 1/2 is what I want to write here. That's not an ordered pair, that's an interval. From the time x is -1.5 to 1/2, I'm increasing. Where I'm decreasing was from -infinity until I hit -1.5. Okay, I'm decreasing, decreasing, decreasing. Oops. And then I'm decreasing again from the time x, so in union with, from the time x is 1/2 to infinity. I know it looks like I'm going to -infinity. That's on the y-axis. I'm talking about the x-axis. X is getting bigger and bigger. Y is way down here. I don't even know where. Okay, it's way off my graph. But I'm talking about the x-axis. So from the time x was -infinity until x was -1.5, my function was decreasing. Also, from the time x was +1/2 and until x is infinity, it's always going to be decreasing from there to there. Okay, let's look at this one. Oh, well, it'd be nice if that was moved over, wouldn't it? So you could see the graph. Okay, here we go. I lost my little arrows. All right, so is this a function? Absolutely. You can see that it passes the vertical line test. Domain and range, well, looks like x can be anything, so the domain's all reals. But my range looks like as low as it goes is -3, and then up to infinity. So my range is -3 to infinity. My y coordinates are never going to be any lower than -3. Okay. What do you think? If I fold it on the y-axis, does it look exactly the same on the left and the right? Does it have symmetry? Yes, it has y-axis symmetry. So therefore, the word we use for that is, this is an even function. It has y-axis symmetry. Y-axis symmetry means it's an even function. Now let's look at this for this new stuff. My function is increasing. In other words, the y coordinates are getting bigger, okay? From the time right here, from the time x is 0 until infinity. It was decreasing from the time x was -infinity until I hit 0. That's when it's decreasing. Increasing from 0 to infinity. Where's it decreasing? From -infinity to 0. Okay? Here's another function. Yes, it's a function. Domain and range look like all reals again. Okay, didn't give you rough functions here. Okay, we're going forever in each direction. This is the graph of 2 cubed root of x. Okay. Symmetry. What do you think? If I fold it right on the y-axis, no, it's not quite right. But it does have symmetry. It has origin symmetry. Okay. Let's look at the points. Let's see, we have 2, 2.5, and I have -2, -2.5. I have 1, 2. I have -1, -2. Okay, so do you see what I mean? It's symmetric across 0, 0, across the origin. Where is it increasing and where is it decreasing? Let's see, I'm going up, 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 I'm going up. It's never decreasing. It's increasing always. Okay? Decreasing never. Increasing from -infinity to infinity. Okay? This gives you some ideas of how we're looking at these functions. Guys, we're going to have to, as soon as we see we have an absolute value function, I want you to picture a V. Okay? As soon as you see that, I want you to realize the domain of an absolute value function is all reals. The range of the absolute value function is from 0 to infinity. Now notice that's just the general parent function of absolute value. It's increasing from 0 to infinity, yet it's decreasing from -infinity to 0. And it's symmetric about the y-axis. Let's look at x squared, the square function. Sorry. This is called the absolute value function. This is the square function. Exact same domain, exact same range, exact same increasing and decreasing intervals, symmetric about the y-axis. 2 different looking graphs though. One's a parabola and one's a V. The square root function. Notice its domain. It's the first one. This is not all reals anymore. 0 to infinity is all you're allowed under the square root, and as a result, the only y's we get are from 0 to infinity as well. It's increasing from 0 to infinity. There is no decreasing. There is no symmetric. Okay, just some things about the square root function. The cube function. Y equals x cubed. Let's think about what that has for its characteristics. The domain this time are all reals, and the range is all reals. Okay, unlike absolute value and square function where the range was just 0 to infinity. We have all reals when I cube it. And it's increasing always, it's never decreasing, and it's symmetric about the origin. Same as the cube root function, but yet looks so different. The domain and range are all reals. It's always increasing, and it's symmetric about the origin. But it's the cube root function. How different they are, even though they have the same characteristics. So fascinating. Greatest integer function. This is designated by these 2 little brackets. Okay, they're double brackets. The domain is all reals, but the range are only integers. The range is all numbers n such that n is an integer. Okay, this is a constant function on every integer. Okay, it just takes the greatest integer less than or equal to x. So for example, the greatest integer of 2 is 2. Okay, 2, 2. The greatest integer of 2.1, the biggest integer less than or equal to 2.1 is also 2. All right, until I get to 3, and then it'll be up to 3. All right, so they call it, you guys probably remember it's called the step function. I know you've had this before, but it is a function. Okay, so I really want you to have an idea what these are. As soon as someone says absolute value, I want you to picture the V. if as soon as it's a quadratic, you know it's going to be a parabola. You might be shifted all around, but it's going to be a parabola. Square root functions, this little hooky thing. Cube function is, there we go. Cube root is a little bit slower. Similar, but, slower. And then the greatest integer function. These are some common functions that we'll be referring to often. And it's good to know all these characteristics before we add and subtract things from them. We are going to do a little bit with something called piecewise functions as well. All right, this is used quite a bit in calculus. It's when a function is defined in little pieces. So my function is x squared as long as x is less than 2. Okay, so I'm going to pretend like it equals 2 just for a minute, and then I'll put a hole there. If I could put 2 in here, I'd get 4, right? 2 squared is 4. So 2, 1, 2, 3, 2, 4, but I'll put a hole there because I can't actually be 2. 3 squared is 9. Okay, I know what the parabola looks like. Oops, let's pretend like that's 3, 9, sorry. And so I have my square here from the time. Oh, it's actually less than 2. Oopsies. Not greater than 2. Less than 2. 1 squared is 1. 0 squared is 0. Negative 1 squared is 1. Negative 2 squared is 4. So there we go. That's what I have when I'm less than 2. When I equal 2, actually the y value is 6. When I'm bigger than 2, I'm the line 10 minus x. So if I could put 2 in here, that would be 8. But I can't, but I want to know where I'm starting. When I put 3 in, 10 minus 3 is 7. When I put 4 in, 10 minus 4 is 6, etc. It's a line that goes down. There's my piecewise function. Wow. Strange looking, huh? It's x squared whenever I'm less than 2. As soon as I hit 2, I'm 6. And then when I'm bigger than 2, I'm the line 10 minus x. Okay, it's a graph defined in pieces. Here, h of x is 2 when I'm less than or equal to 1. So when I'm 1, my y-coordinate is 2. When I'm 0, my y-coordinate is 2. When I'm negative 1, my y-coordinate is 2. Oops, oh gracious, I wish I could draw straight. That's just right on the line, okay? It's a horizontal line there. Sorry. When I'm bigger than 1, I'm x. So, bigger than 1. So when I'm 2, I'm 2. When I'm 3, 3. 4, 4. It's the line x whenever I'm bigger than 1. Okay, it would be 1, 1, but it's telling me here that I'm up at 2. So here's the line y equals x. That's only whenever I'm bigger than 1. As soon as I'm 1.1, 1.1, 1.2, 1.2. Okay, it's the line y equals x. That's a piecewise function. Okay, here I have negative 0.5x cubed plus 2 when I'm less than 0. I know what x cubed looks like. This negative 0.5 is going to compress it a little bit, and I'm going to flip it around. But I'm only less than 0, so negative 1 cubed is negative 1 times negative a half is positive a half plus 2 is 2.5. Okay, that's what happens when I put negative 1 in. When I put negative 2 in, negative 2 cubed is negative 8, but half of negative a half times negative 8 is 4, plus 2 is 6. Okay, so I know that I know how this works. The 0 is 2. Whoopsies. Okay, but I have to just be less than 0, so that's a whole. Okay. Between 0 and 4, I'm 2. 0, 1, 2, 3. 0, 1, 2, 3, 4.